Now, in these programs or in these problem students, we have looked into a type of a problems where there is only one magnetic tape is given with us. There is only one magnetic tape. All these n programs are going to be stored on a single magnetic tape. So there can be another type of a problem where we have multiple tapes. Okay, where we have multiple tapes. If there are multiple tapes and n number of programs, then how we are going to store those programs on the multiple tapes such that the retrieval time, that is mean retrieval time, is minimized. Okay, let us try to understand that concept with a simple examples here. Let me consider that there are, say, 5 programs. So that there are 5 programs. Okay, now say L1, L2, L3, L4, and L5. So the retrieval time of, or the length of these particular programs are considered it to be 6, 4, 7, 1, 5. Okay, now 6 means this length of L1, 4 is length of L2, like that 5 is length of L5. And we have additionally here, there is no single tape, but there are multiple tapes. Consider 2 tapes are given with us. 2 tapes means physically there are 2 different magnetic tapes, and on those 2 different magnetic tapes we are going to store these 5 programs. It is like we are not going to duplicate them, we are going to pick few of them. Few will be placed or stored on one tape, and the remaining will be stored on second tape. Okay, now the strategy again here, it goes in the same similar way. First, we will try to rearrange them in a ascending order. Okay, so first rearrange them. So after rearranging, what we can have, say, first 1, then 4, 5, 6, and 7. So 1 is nothing but what? It is L4. Then 4 is L2. Then 5 is L5. This is L1. Then this one is L3. Okay, now we have placed them in a, we have rearranged them in a ascending order, because we know that if we arrange them in a ascending order as per their lengths, we can have the optimal solution. Okay, the retrieval time is less if we arrange them in an ascending order. Now we have 2 tapes. I can call it to be T0 as first tape and then T1 as the second tape. T0 is the first tape and T1 is second tape. How we are going to store them is, on T0, the first program. The first program means after rearranging whatever program we get, the first one, that we are going to store it in T0. So that is nothing but L4. Okay, now next is, after rearranging, we have a second one. This second one, we are going to store it on the next tape. Next tape here it is P1, that is here L4, that is L2 will be placed or stored on T1. Okay, now first 2 are done. Now you can think here. Okay, the next one, that is L5, we are going to again place it in T0, that is L5 here. Okay, then next one is what? L1. This L1 will be now stored or placed on T1. So L1 will come over here. Now we are left out with only one program, that is L3. This L3 will be now placed where? It will be placed on the T0 plus L3. If you look at the pattern here, after rearranging all the programs with respect to their ascending order length, one program will be placed on first, the next one on the second. Then again third, we will again come back to the first, and then we will move on to the next. So one after the other, alternatively, we are going to keep or store our programs. If we store in this order, the retrieval time and the mean retrieval time is going to be minimized. Okay, now let us try to calculate those particular values here. First, what I will do, I will first calculate the retrieval time or the mean retrieval time of T0. So mean retrieval time of T0, mean retrieval time of T0 is equals to L4. To retrieve L4, we require a length of 1 plus, to retrieve L5, L5 means 1 plus 5. It is going to be 1 plus 5, 1 plus 5, then plus L3. So L3 means previous to, that is 1 plus 5, then its own value, that is L3 as 7. So if we add these values, how much we get? Is it 20? Yes, 20. So mean retrieval time means this is actually retrieval time. Then MRT, that is mean retrieval time of T0, is going to be 20 divided by total number of programs on T0 is 3, that is 20 divided by 3. So that we get it to be 6.66. Similarly, let us first calculate the retrieval time of T1 tape. So that is going to be what? L2 plus L1. So L2 is what? 4. We get it as 4 plus, next one is L1. L1 value is what? In order to access L1, first we need to go through L2 first. That is going to be again 4 plus 6. Right? So that we get it to be then MRT of, that is mean retrieval time of T1, is equals to 14 divided by total number of programs that are stored on T1 is 2 divided by 2. So we get as 7. Right? Now, if you look at here, we are individually initially calculating the mean retrieval time, that is mean retrieval time of T0 and mean retrieval time of T1 with respect to its own or the different tapes. Now, to calculate the total retrieval time or the total mean retrieval time, you can say total mean retrieval time is equals to sum of its individual retrieval times, that is going to be 6.66 plus 7 whole divided by 2. By 2 because there are two different tapes divided by 2. So if we add and divide by 2, we get approximately around 6.83 in this case. So in this particular example, we looked into a multiple tapes. Means we are given with n number of programs and associated with its own lengths. But we are also given with multiple tapes. So when we are given with the multiple tapes, we need to store or place those programs on those particular tapes. How we can do that? First, rearrange them in an ascending order according to their lengths. After doing that, since we are given with the two tapes, we can name them to be T0 and T1. So on alternative basis, we will keep on storing the programs on T0 and T1. Right? So L4 first on T0, then L2 on T1, then L5 on T0, and then L1 on T1, then the remaining L3 on the T0. Once we make that arrangement, then we are supposed to first calculate retrieval time of T0 and then the retrieval, that is mean retrieval time of T0. We have to take care of calculating the MRT in this case, because the total number of programs are 5, but while calculating the mean retrieval time of T0, we need not to consider all 5 programs, because we are not storing all those 5 programs on the T0. Rather, we are only storing 3 programs. So it is going to be 20 divided by 3. In the same way, the retrieval time of second tape is calculated, and then the mean retrieval time. Again, here mean retrieval time is divided by the retrieval time is divided by 2, because we are only storing 2 tapes, or the 2 programs on T1 tape. Once the individual MRTs are calculated, that is mean retrieval time is calculated for the respective tapes, in order to calculate the total mean retrieval time, add them and divide it by number of tapes, so we get the value. So this value is going to be the mean retrieval time in case of multiple tapes. So let us take another example, students. Here we have 12 programs and 3 tapes. So the length of all those 12 programs are like this. First step is that we need to rearrange them in an ascending order. So after arranging them in an ascending order, rearranging, we get the programs in this order. That is L9, L8, L2, L5, L12, like that up to L7 we get. Since we are given with 3 tapes, so T0 I can name as the first one, T1 as second, and T2 as the third. Now, let us make it simpler in this case. So how we are going to store them? First one is L9, so that L9 is going to be stored on T0. So L9. The next is L8, that L8 will be stored on second tape. So L8 will come here. Then third is L2, that L2 will be stored on the next tape in this case, that is T2. So L2 will be here. Then L5, so we have stored one program on 3 tapes. The fourth one we will come back and store on the first tape again. So here we get it to be L5, right? And then the next one, L12 here, then L4. Okay. Next, after L4, L3, that L3 will be again stored on T0. So L3. Then we get L11 and then L10. Then again, the L6 will be on T0 and then L7 on T1. Did I miss anything here, students? Let me cross check. 9, 8, 2, 15, 12, 4, 13, 11, 10. Then, yeah, here it is 11 and here it is 16. Sorry, L6. And then here I have L7. Okay, now let us calculate the retrieval time of T0. So retrieval time of T0 is going to be L9's value. So L9 value is 3. So 3 in this case, plus then L5. So L5 value is what? 5. So it is going to be 3 plus 5. Okay, then L3. So L3 is what? 8. L3 is 8. So that is going to be 3 plus 5 plus 8. Then the last one is L1. So L1 is 12. That is 3 plus 5 plus 8, all the previous values and its own length, that is 11. Sorry, that is 12. L1 is 12. So if we add all these values, so we get the sum to be 55. This is retrieval time. Okay, now we will try to calculate the retrieval time. That is, we can go in the other way also, students. We can first initially calculate the retrieval time, then later we can calculate mean retrieval time also. Any order we can have it. So let me have mean retrieval time of T0 equal to 55 divided by the number of programs which are stored on T0, that is 4 in this case, divided by 4. So we get something approximately around 13.75. Not approximately, the exact value is 13.75. The same way, let us calculate retrieval time of T1. So it is going to be L8. L8 value is 4 plus. Then next one is L12. L12 is 6. So 6 is nothing but 4 plus 6. Okay. Then next is L11. So L11 value is 10. So we get it as 4 plus 6 plus 10. Okay. Then the last one, retrieval time of the last one, that is L6. L6 is nothing but 18, but we need to have the previous values, 4 plus 6 plus 10 plus, that is L16. L16 is 18. We get as 18 here. So let's add all these values. We get it as 72. Okay, then mean retrieval time of T1 is going to be 72 divided by, again, 4, because 4 programs are stored on T1. So 72 divided by 4, we get as 'Now, next, retrieval time of T2. So T2 is L2. L2 value is 5. So we get first as 5 plus. Then next one is L4. So L4 value is 7. That is 5 plus 7. 5 plus 7. Okay. The next one. Next one is going to be, let me write the 5 plus 7, and then L11. L11 is 10. Sorry, L11 is, yeah. Here the L11 is 10. So 10 means the previous two values, 5 plus 7, and then plus, that is, sorry, L10, that is 11 value. We get it as 11 here, plus, then the last one is L7. L7 is 26. So 5 plus 7 plus 11 plus 26. So let's add all these values. So we get the sum as 89. The mean retrieval time of T2 is 89 divided by total number of programs stored on the tape 2, that is 4. So the MRT is going to be 89 divided by 4. We get it as 22.25. So these are the individual mean retrieval time of the individual tapes. Now we need to calculate the total mean retrieval time. So total MRT is equals to the first one, that is 13.75 plus this value. Okay. Second is 18. So plus 18. Third is 22.25. and then we need to divide them by 2. Sorry, 3, because in this case there are 3 tapes divided by 3. So we get the answer to be, so if we add here 22 plus 18, that is 40, 40 plus 13, 53, 53 plus 1, that is 54, 54 divided by 3. So we get the value as 18. So 18 is the mean retrieval time for this particular problem. So you may get there is a chance of getting a 5 marks question also. If it is a 5 marks question, then definitely you get a lengthy like this. You may get a more number of programs and multiple tapes problem. So in the multiple tapes problem, usually students will make a mistake of calculating the MRTs here for individual tapes. So if you can take care of calculating the MRTs of individual tapes, then the final value will come to be